Hello dear students. Today we will see how to remember theorem of perpendicular axis easily. You cannot modify the definition. You have to write the same definition. But I'll tell you how to remember this definition easily. Okay. We'll read out once. Moment of inertia of a planar body. Okay, this is important. Theorem of perpendicular axis is defined for planar body. It should be planar. Okay. And what about its axis? Its axis should be perpendicular to its plane. Okay. Theorem of perpendicular axis is applicable for a planar body, point number 1. And the axis of rotation should be perpendicular to its plane. Axis should be perpendicular to its plane. Let me draw a diagram. We have to consider one planar body. Okay, so this is the planar body. Now, theorem of perpendicular axis is defined for a planar body, correct? And we should consider an axis perpendicular to the plane. Okay, we have considered. Say this is Iy, moment of inertia, okay, of this axis, let it be Iy. Okay, this should be equal to, okay, this should be equal to sum of its moment of inertia about two perpendicular axes. How those two perpendicular axes should be? They should be lying in the plane of the body and they should be concurrent with the perpendicular axis. Means now we should consider two mutually perpendicular axes. Say this is x-axis, corresponding moment of inertia is Ix. Say this is z-axis. Okay, the corresponding moment of inertia is Iz. Now if you observe, okay, this Iz and Ix, okay, these two are perpendicular to each other. They are mutually perpendicular. And these two are concurrent with the perpendicular axis. These two are concurrent with the perpendicular axis. And one more thing is these two lie in the plane of the planar body. They lie in the same plane in which planar body is there. Okay. So if you have to write in the form of equation, what we have to write? Iy equal to, what is Iy? Iy is an axis perpendicular to the plane of the body. Okay, that is equal to sum of, okay, sum of moments of inertia of two mutually perpendicular axes, which are concurrent with the perpendicular axis. So sum of Ix and Iz. Now hope you can remember this definition easily. So what we have to do? First we have to remember that theorem of perpendicular axis is applicable for a planar body and it is defined for an axis perpendicular to its plane. So first what we have to do? First we have to consider an axis, okay, which is perpendicular to the plane of the planar body. And moment of inertia of that is equal to sum of moments of inertia of two mutually perpendicular axes, and they should be lying in the plane of the body, okay, and they should be concurrent with the perpendicular axis. So this is theorem of perpendicular axis. We will repeat once again. Moment of inertia of a planar body. Okay, here we have considered a planar body. Moment of inertia of a planar body about an axis perpendicular to its plane. Okay, we have considered one axis perpendicular to the plane. Okay, is equal to okay, the sum of moments of inertia about two perpendicular axes. Moment of inertia of two perpendicular axes. Okay, these two are the perpendicular axes. Okay, concurrent with the perpendicular axis. Okay, those two should be concurrent with the perpendicular axis. Those should be concurrent with the perpendicular axis, and they should be lying in the plane of the body. These two perpendicular axes, they should lie in the plane of the body. Thank you very much.